Thank you so much for inviting me. I'm very happy to give this talk. I'm Sara Falcone. I'm an assistant professor at Pace University, which is based in New York City. And today I will talk about my research, which is about unraveling the complexity of the sense of embodiment in teleoperation. My research is about trying to enhance this feeling of embodiment in teleoperation. So the idea that we want to feel this feeling of ownership and agency over the avatar that we are controlling. In general, when we talk about an avatar, we can define an avatar as, of course, in my case, mostly we're talking about telerobotic setups, but an avatar could also be an avatar in VR, and I did experiments on that, or an avatar can just be a rubber hand. I guess this could ring a bell, but we'll go back to that. So the first question is, what is the sense of embodiment? I have this example that I like to present every time I was having this talk with a professor of chemistry. So we were definitely studying different things. And I was trying to explain this concept of embodiment. And then he came up with this answer. Actually started with the question. He asked me, do you ski? And I was like, oh, well, I'm from the south of Italy. We don't really ski there. I tried once. It was awful for me and for the others to see. And then he told me, well, when you ski, you start to feel like the skis that you're using are an extension of your body. They actually become your own body. You don't feel anymore that you're using a tool or an object in order to accomplish whatever task you're doing, like in this case, skiing, but you actually feel like you're completely embodied with that. And I felt this was a great example because I absolutely couldn't feel the same. For me, like using skis felt like using something which is completely not connected with my body. I didn't have any control over it. And for me, it was very difficult to accomplish any kind of task using this extension. This was, let's say, my starting point in the regards to think about, okay, so when we think about embodiment, extension of our avatar or body, what do we mean? So I like to start with this short video. I saw that Camille gave a talk before me, he was very well involved actually in this project, and my department was part of this worldwide competition, the Anna Avatar X Prize. So the main aim here was to create a team. In our case, it was a team with researchers from all over Europe and also companies. And we wanted to create this flexible telerobotic setup to control different kind of avatars for different contexts of application. So I like to show this video just to give an idea of what is the final purpose of what I do, in the sense, what is the aim with all the, let's say, the experiments and the data that I collect, what is the actual application. This was actually the fun fact is that when it was the time of this competition, there was the pandemic. So everyone was working on a teleoperation setup in remote, which was very, very challenging, but also very up to the point in some way. So you can see here the cabinet that was used to control the setup. We have several haptics devices to provide force feedback. This is a cabinet from Sensic, which is a multi-sensory kind of cabinet that can also provide, for example, olfactory feedback, aside from placing all the haptics devices that we needed, VR headset to give visual immersion. So in these two trials that I briefly show, I won't show the entire video, we will see the operator from the Netherlands controlling the animal, which is this animatronic kind robot that from the ETH in Zurich. And then there would be a humanoid robot, Eve, from Allodi, this Norwegian company. So for example, in this case, you can see that the task was to control a quadruped robot with an arm and a hand, humanoid hand, untouched on the top. So you can imagine the difference of a task of using a field robot like this one, which is usually used in hazardous environment for field robotics, right? And then the difference of using something like that compared to using a humanoid robot, like in this case, for example, the task of opening an oven, right? So feeling the force feedback, feeling properly in order to don't put enough, too much pressure, not enough pressure, and then doing pick and place with an object, and of course, controlling completely different kind of body. So this is, let's say, the final application, but how do we come to that? And why do we care about embodiment when we talk about these kinds of setups and systems that are becoming more and more spread? Well, when I talk about sense of embodiment, the main framework to which I refer to is made by three main components: ownership, agency, and self-location. Where ownership is this feeling of self-attribution. So I feel that this avatar that I'm controlling is actually my own body. The feeling of agency is the feeling of control. So if I perform an action, I feel like I did this action. And self-location is the volume of space. So I feel that the volume of space that is occupied by the avatar, even if the body that I'm controlling has a different size or dimension, I can perfectly be aware of how to move this body and the place that it occupies in the space, in the volume of space in remote. So um, the very origin of this concept of embodiment, we can refer into this idea of the rubber hand illusion. If you're not familiar with that, the rubber hand illusion is an experiment in the field of cognitive science. This was designed by Bottomnik and Cohen in 1998. And basically here, the idea was to test this concept of the plasticity of the brain. So the experiment consists of placing a rubber hand in the place where you actually should see your own hand. Usually we're talking about the right arm. And then your actual hand is placed either below the table, or you place a piece of cloth in order to cover your shoulder and the arm. During the experiment, there is some stroking happening to the hand, maybe a brush on the hand. So you have like this synchronicity of the visual feedback and then the tactile feedback, because at the same time also your hand is stimulated in the same way. And then at a certain point, your real hand won't be stimulated anymore. You will just see visual feedback. But if the illusion happened, then you will feel that whatever is happening to the hand, to the rubber hand, is also happening to your own body. And you can see a knife there, because one of the open challenges in measuring embodiment is actually how to properly measure it. Do we have some standard measures? And the answer is not really, not yet. But we have, let's say, we have measurements which are qualitative and quantitative that we can use together in order to get, let's say, a proper picture of the level of the embodiment of an individual. So qualitative measures like validative surveys or questionnaires, and instead quantitative measures like, for example, physiological measures mostly. So skin conductance response is the mostly used. In my studies, I was testing pupil dilation as another measure of embodiment, because the idea here is trying to understand if there is engagement, arousal, and since usually in teleoperation setups, there is always the usage of a VR headset, this was very convenient in order to not touch other devices on the operators while controlling, for example, an avatar. And so the idea is that if you can record a significant difference in the signal at the moment of the threat, like for example, stabbing the rubber hand, or maybe using a hammer to smash the rubber hand, something that can scare the participant, then that would be a measure that you were actually feeling embodiment with that hand, put of course in combination with the qualitative measure that we can have. So this is the original idea. And how can we go from cognitive science to engineering applications? So of course, lots of questions arises there. And so how can we make this transition? Which measure do we use? What is the effect of using a mediator when you're controlling an avatar? And by mediator, I mean, in this case, the setup, right? Because if we are controlling a VR avatar or a robotics device, the idea is that we're gonna wear, as I was showing before, for example, some haptic gloves, and we will have like a VR headset, and we will try to let the operator feel immersed in this remote scene. And so how can we do that? So in my initial experiments, I was starting to do this sort of transition, right? So my idea was to try to replicate a rubber hand illusion, but in VR. However, not using yet an avatar, or at least not using yet a virtual avatar. But in this case, this was exactly the same setup of a rubber hand illusion, but participants were observing a pre-recorded video of an actual hand wearing a glove to avoiding, let's say, like difference that could be done, for example, by observing a different hand, a different nails, a different skin, and so on and on and on. And so we were just stimulating in synchronicity or asynchronicity according to the condition, the hand that the participants were looking at. So these were really preliminary experiments. So we were trying to study, for example, the pupil dilation as a proper measure of embodiment. We weren't trying to see the effects of adding this mediator in between the human who is embodying another surrogate, in this case another human body, for example. And so you can see here me and my students that were performing the experiments, and this was really our first starting point. So the idea there was, okay, we understand that there is an effect of the mediator. We have seen that, of course, it makes the difference to observe the scene using like an entire setup. And we know anyway that when we talk about engineering applications, there is a difference. How can we translate the rubber hand illusion into engineering applications? What is the main difference there? And the main difference there is actually that in those cases, we have an active experience and we underline the sense of agency. Why? Because, of course, when we talk about an avatar and we need to accomplish some tasks, we are going to perform some actions. It's not just us observing what's going on and what is happening. It's not anymore a passive experience. The active experience takes the lead there. Even if we are in a context in which we are not really manipulating objects, even if for some reason we are immersed and we are trying to control a robot, which could be like the Roomba robot, right? So a cleaning robot, for example, and we're just there in a remote environment, roaming around in a room. That's the same. We are trying to feel immersed. We're occupying a different volume of space. And in that moment, we should feel embodied with our robot. We should feel embodied with our robot to improve our task performance, to improve the user experience, because these were the hypotheses that we tested later on, because our idea was like, why do we care about embodiment when we are in such kind of applications? And the idea is that we care about it because it could reduce, for example, the training time that we need to train an operator to use the system. It could reduce the workload, which means that we can use the system for prolonged times. And of course, it can also improve task performance. Now, to understand how we actually, our brain actually process this concept of the sense of agency, we refer to the predictive coded theory. So what is the idea here? So we have a predicted sensory consequences. So I perform an action, I have some expectations about what is going to happen, how it's going to feel. And then there is an actual incoming sensations. Usually when we use our own bodies, so imagine that you're touching, for example, a marble table. And even before touching it, you infer how it's gonna be. You can infer that it's gonna be solid, it's gonna be cold, for example, and all these kind of things. So how does it work in the brain in that sense? So practically we have our sensory input coming and we have already a predicted error, as I was saying before. And then in the premotor cortex, we have the action initiation. So we actually perform the action, right? So we have the signals that goes in the rest of our body to say, okay, this is the action that we need to perform. Then we have a multisensory comparison that happens in the parietal cortex. So it means that we basically are comparing the predicted error with the actual error that we computed. And finally, in the insula, there is the part which is more related to this concept of brain plasticity. So in the insula, we have the idea of self. So why do we feel that we are performing something? Why do we feel that we are that body and all this sort of feeling and perception? So in the insula, we have, let's say, the final results of, okay, so this is the difference in between predicted error and the actual error. How do I use that? What do I do with this? So as I was saying before, we can say that, for example, a low predictor error means high sense of embodiment. So I feel like I did the action, when a high predicted error means a low sense of embodiment. So something else, someone else or something else did that. Now, since we were starting with this transition, then we moved to another VR experiment in which we wanted to test 5 perceptual cues together. So we took the main perceptual cues that were studied in the literature and that were either alterated for during the experiments, for example, the field of view, the connectedness, visual proprioceptive synchronicity, human likeness, and tactile feedback. The idea here is that we wanted to test these cues together because we wanted to check if there was actually an interaction effect that we did not find. And then here the participants were performing a very simple task, like touching a grid with their virtual hand in a certain amount of time. And there were the conditions were either supportive or suppressive. And the participants were testing all this combination, all these cues, supportive and suppressive, for all the duration of the experiment. So they had 32 trials, one for each combination, and then they were evaluating each of them. This is an example of a possible combination, right? For example, field of view suppressive, at the same time, the visual proprioceptive synchronicity is supportive, tactile feedback supportive, and so on. To give you some idea of how it worked, here we can see, for example, a completely suppressive condition. This was what the participant was seeing. Completely supportive condition, what the participant was seeing instead on the right. We actually managed to find a ranking there. So I was saying no interaction effect, and there was a ranking of these perceptual cues. The interesting thing is that for all the dimensions that we were studying, ownership, agency, location, self-location, and task performance, the visual proprioceptive synchronicity was the one that affected the most all of them. And the visual proprioceptive synchronicity, you can imagine it as the delay. So I make an action, but there is some delay in observing this action accomplished by, for example, my hand moving. So starting from there, we wanted to focus on the visual proprioceptive synchronicity. So this other experiment was really about studying this main role. And so we realized, again, an active experience of the rubber hand illusion. The task was very similar. So this was the calibration that you can see in the picture, but they were actually touching a grid very similar to the one that we were seeing before. And this grid, they just needed to touch the dots that were highlighted it. Exactly as we were seeing in the previous experiment, this was mixed reality because they were using they were seeing the table and they were actually touching the actual table. And the idea here was, okay, let's try to use the same conditions that are used in the classic rubber hand illusion, so the hand shift. And so we were moving the hand, we were misplacing the hand, either horizontally or vertically on the plane, compared to the actual position of the right hand of the participant. And then we have the condition in which we have synchronicity or asynchronicity. What we found out here is that the shift didn't really have an effect. And again, let's pay attention to the thing that here we're talking about an active experience. So we are in a different dimension of this concept of embodiment when there is some action involved. So the asynchronicity played in effect for all the dimensions that we were testing, which were again ownership, agency, self-location, and task performance, but no effect given by the shift. So it was not important that the hand was misplaced, but the thing that really affected the embodiment and the task performance was the asynchronicity. Finally, we decided to implement these results in a telerobotic setup. So we're like, okay, interesting to notice that for embodiment, visual proprioceptive synchronicity is a problem. And we know that in telerobotics, latency is our main number one enemy, right? So what do we do here? We design a telerobotic setup. And in this telerobotic setup, we designed a controller that was implemented with a predictor. This predictor was based on the EMG signal coming from the arm. So what we were doing there, the idea was to create a control that could perform well with latency. And we were comparing that with the control with the passivity layer, and that usually is pretty unstable, especially with latency. And so we wanted to create something that was more stable and that the user could perceive as most stable. Now, the interesting thing of creating something like that is that when you have a predictor that is calibrated on some training that is done at the beginning by the user, and you are trying to predict the initial movements, at least of the participant, because how do we increase the stability? We can predict how the user is gonna go, which is gonna be the movement of the user, by using this predictor. So there is some semi-control there just in the initiation of the action. And what we could find out is that our controller, in the case of latency, was perceived much better. The embodiment was better, task performance was better. So this is an example of the task is a press on buttons, that's how I would call it. But basically, we were just, it's very similar to the grids that I was showing you before. So the idea even there was to try to get at least some consistency, even if we're switching from, let's say we start from the actual rubber hand illusion, then we go to VR, and then we finally go to telerobotics. We were using a Franca arm there, we were using a gripper. And from the other side, you can see that the participant is controlling this arm. And in this case, we didn't focus on the immersion, for example, given by the headset. The participant was using a display to observe the scene. Then we decided it was time to also have a more explorative study, because we found out which was the most important sensory cues. This was very consistent. We saw that it made the difference even in the final application when we had our telerobotic setup. But then we were thinking, okay, but was this, how can we actually define what does it mean to feel embodied with something? And what does it mean to feel embodied with something? What is the role of this mediator that we were defining before? So in this case, we have a mixed study. So both within and between subject design, in which we have the supportive conditions. We have the same subject performing the same task, once using their own hand, and then using the robotics device, the robotics setup. And then in the suppressive condition, instead, you can see exactly what the participants were seeing while they were performing the task. So they were seeing themselves in third person perspective, mirroring view, and they were first doing their task using their own hand, and they're using the robotic device. Now, what was interesting to see here is that no matter the condition, supportive or suppressive, participants weren't feeling less embodied with their body, even if during the suppressive condition and even for the supportive one, even when they were using their own body, they were wearing a VR headset. So there was a camera pointing on the workspace. And in this case, for example, for the suppressive condition, you can see that even to reduce some sensibility to the hand, we were using some gloves and they were filled with other pieces of clothes. So we were, of course, altering even the synchronicity in that case. And the interesting thing is that none of the participants felt less embodied, significantly less embodied with their own body. And even the task performance, it was poor at the beginning, but the learning curve was incredible. And so they managed to perform as well as in the supportive condition. Instead, the interesting thing was in the suppressive condition for the robots in particular, because in the supportive one, we could see that actually the learning curve also was pretty high for the supporting condition with the robot body, but in the suppressive condition with the robotic body, instead there was a significant difference in between the two performance, in between the robot, in between the supporting, the suppressing condition using the robot. And so the idea is to understand, okay, so in this case, it didn't feel even if we were altering the sensory cues. As soon as you can use your own body, then it doesn't really make the difference. Then you still feel embodied. But why is it the case? Like, why it's still like that? It's because we are used to use this body. It's because we know exactly how to use it. And then if we would train enough with something else, it would be the same. What does it mean to feel embodied with an avatar at this point? This is a short video just to show you that's exactly what the participants were seeing while performing the task. So, what is the sense of embodiment? After I talked for 20 minutes, we found some answers, but we still can see that there is so much to explore. And since I started my talk with a story, I would like to conclude it with another story about my grandma. So my grandma used to be a seamstress, and she basically sewed for her entire life, and she used to tailor me incredible dresses. And last year I was having a talk to her, and she was telling me that now her tactile feedback basically is almost gone. She still does something, she still tailors, she still see, but the thing is that she's much slower in accomplishing the task. She can feel less, and it became much more difficult. However, it's very impressive. The thing that even if she takes more time, and even if she's learning how to use this new body for which the sensory cues that she's getting are just elaborating and computed in a different way compared to maybe already 10 years ago, then the idea is that she managed, she understood how to use it. And as in the experiment that I was showing you before, in the suppressive condition, right, with the human body, she can learn and she can adapt and she can accomplish the task in an excellent, great way, exactly as she would have done it before. It just takes more time. And she has like a limited perception of the cues that are coming from all the tools that she's using and the things that she's touching, for example, and the task that she's trying to accomplish, right? And again, we come back here to using a tool as an extension of your body, like all the tools that she were using to do that. They basically became part of her. Is not anymore like an external tool. She can use them as they were like an extension of her fingers, for example. So this example in particular doesn't have, let's say, a particular main purpose to say this is embodiment. It's just to say that anyway, this concept of embodiment, we find it in everyday life in some way. I can talk with my grandma about embodiment without talking about my research, and she can perfectly understand what I talking about in some way, right? If she related to her own experience, and I can relate so much of her to my own research. So to conclude, because I know that I'm almost out of time, we could see that sense of embodiment is a critical factor to improve task performance and the teleoperator experience in teleoperation. We have seen that there is a main effect of the sense of agency, and to support this, and it's important to enhance the feeling of embodiment to support motor learning and adaptation. And we could prove that spatial proprioceptive synchronicity is the main cue on which we should focus, at least, of course, like among all the other cues, that was the one that had a main role. Future works optimize, of course, this issue, which is related to the synchronicity in the setups that we're trying to realize, explore more in depth how the predictive coding theory can help us in designing, for example, sense of agency, investigating the long-term effects. So if actually we can have like using embodiment, having and enhancing embodiment can also create like overall creating over and over during the time using always the same avatar could actually let us feel as this avatar is really our own body, and reducing this distance in between us and the avatar, even if we're using a mediator. And then also trying to understand if there are other interaction effects among the different components of embodiment, like ownership, agency, and self-location. So try to really disentangle those. Thank you so much for your attention, and I'm here for questions.
Now, okay, so thank you so much, Sara. It was great to, again, shift gears. I think we were talking much more now about perceptual presence and being there to be able to manipulate an object in some kind of spatial temporal synchronous way. Are there questions in the room? I know there are. There's one from Asaf. Go ahead, Asaf.
So thank you. There's this literature. I mean, I know it's a literature, but I just know there's this work where they use this kind of delay. They habituated people on a certain delay. It was like very small, and they got used to the delay with like some mechanical arm. And then they eliminated the delay, and people felt they were not in control anymore. It was kind of a model of schizophrenia or something, right? So I'm just wondering if you would replicate that with your two conditions, the hand versus the robot, and how would that be? Would it be different? Would people have different responses to when a robot behaves kind of with self, with like not me making you do it versus my own hand maybe, and then whether that would be an interesting measure of of embodiment, to what extent like if a robot hand does something earlier than I expected, would that have a different interpretation than if my own hand, say, let's just speak, does that? Anyway, just some kind of thought about.
Yeah, that's actually super interesting, especially because one of my main, let's say, one of the points that actually I wanted to study is to understand which is this threshold of the delay. So how much can we actually deal with that? Because there is for sure a threshold after which one you're like, okay, this is not anymore delay. This is me trying to guess where for example, the hand that I'm controlling is going at this point, right? So what is the threshold up to which point we can say, okay, this is just like, for example, something that we could use as a measure, something that we can use, like we can introduce it just to see if any way we can feel ownership and embodied, even if we lose a bit of sense of agency, how much our brain can, let's say, adapt to the delay. So I absolutely would love to replicate something like that. But before that, if I would have to do a study related to that, that would be some kind of psychophysical experiment in which you really try to understand, okay, what is the threshold for the delay? It's actually if there is a threshold that in average we can refer to everyone, or if maybe so personal, because this is also another aspect to investigate. So if there are individual differences that can affect embodiment. So if there are people with more proprioceptive information and they're just better at it for some reason. So yeah, great point. Thank you so much. And yeah, absolutely something that I would love to explore, but that would be my preliminary study to do that.